Let's see where we are. Okay, start off with some prompts just to get the brain juices flowing. Good morning. 1A. Okay, somebody go. By complete, I mean simplify, write it a lot nicer. What'd you guys get? Don't be shy, go, tell me what you did. Did anyone finish it? Did you finish it? What did you get?
Let's hope it's right.
Negative
2.
You think it's -2?
Yeah.
Did anyone else get -2? No one else did that one? You got 1/2. 1/2 -2. Okay, any other? Everyone else is like totally lost. We have no idea. Okay, well, let's start. How would you? Okay, so you see that. What are you thinking? Why was it -2? What did you do?
I just canceled.
Cancel what?
Well, the log. I'm not
What rule were you using? Yeah.
Do you bring it to the front, the exponent to the front?
What do you mean?
Like -ln to e, and the ln and e cancel out?
No. What rule says we can bring exponents to the front? Yeah?
No.
So let's say you're telling me, what rule were you thinking about when you want to bring something to the front? The rule we had said what? If we have log to the base a of something to a power, we can take that power and move it down in front. But do we have something that looks like this here? No, this is a logarithmic expression. This is an exponential expression. That rule does not apply. Yeah.
I got 1/2.
Okay, how?
Well, oh wait, no, I got 2 actually, sorry.
You got 2,
Yeah.
positive 2?
Yeah.
So we have a -2, a positive 2.5? Okay. Explain how you got it.
Well, it's a negative exponent, so put it over 1. Like 1 over.
Okay, you can do that. Now what?
You take ln 2, and it's like 0.6. Yeah.
You don't need like a calculator or anything here.
I know.
It's going to be a nice answer. Yes. So in this case, looking at the denominator, you should also remember that we had a rule that says if you have a base and we have log to the same base of something, they kind of cancel each other. It's not really the right word to use, but here, and remember ln just means the base is e, so it means that rule applies. So the e and the ln kind of cancel each other, and so you'd be left with the 2. So the answer is actually 1/2. And that's one way to get to it. There are many ways. Another way could be realizing that ln2 using the laws of exponents is actually that. Right? Remember, because there's a rule that says you multiply the powers. And inside the parentheses, we have e to the ln again, canceling each other. We have 2 to the -1, just again 1/2. Could have done it that way. We have another way of looking at this. Using this rule actually, kind of in reverse. There's a -1 in front of here. I can move this power up according to the rule. So this is 2 to the -1. Now I have E and ln right beside each other. They can cancel. It leaves me 2 to the -1, which is again a half. Okay. Now, moral of the story. Those rules that I wrote down on the board last time, they're very important, and it's very important that you memorize these rules very specifically. The devil is in the details when it comes to calculus, so you have to really pay attention. So for example, I think why you got -2, whoever said -2, is because you just canceled here. Now there's a problem with just canceling there, right? Because what does the rule say? Because that's illegal, right? And you should recognize that that's illegal because it's not in the right form to do that manipulation. So the rule says the following. And so this is a rule that you have. Now whenever I give you a rule, it's very important that you memorize that rule, know it very specifically, know what each thing in the rule is. You should recognize from this rule that I'm thinking of A as a constant that's bigger than 1. So that is a constant that's bigger than 1. My x can be a variable as long as it is greater than 0 to be in the domain of the log. You should understand all that. You should also recognize in this rule that there is no number in front of the log. It's also important to realize what's not in the rule. Here, when this question was presented, you had a -1 in front of the log. According to our rule, there should be nothing in front of the log, which means you cannot apply this rule to that, at least not right away. You need to change it somehow. The base and the log must be kind of like right beside each other. There should be nothing in between them. Okay? So if you want to apply this rule, you need to make sure you're applying it to the right form. Yes?
So I got 1/2 by moving it to the denominator, and then that -1 went away, so then you could cancel.
This one?
Yeah,
Yeah.
that's what I did.
But what you're doing is you're applying this rule
Right, I
in the
understand.
denominator, and
Right.
it's okay now because there's nothing.
Right, and I completely understand that. But if that -1 was instead like a 3, where you can't just move it to the, well, how would you do that?
Well, one of the other two ways then.
Okay.
So let's say you had e to the 3 ln 2 unit. A bunch of ways you can do it. You can think of that as e to the ln of 2 raised to the 3. So that just becomes 2 cubed.
Yeah.
You can also think of it as e to the ln of 2, and you take that 3 in front and bring it up.
Okay,
And then you can cancel that again, and you get 2 cubed in either case.
okay.
But the important thing is this is why you need to be good at algebra. You need to be able to manipulate something to get into a certain form.
That makes sense.
It's going to be that's a very important skill to learn. Okay, I'm going to be giving you a lot of rules and a lot of formulas in this class, and it's very important that you apply them exactly as they're written. And sometimes when a problem is given, it's not given in a form that you have to apply the rule. You need some sort of manipulation to make sure, okay, it fits. You want to look at the rules that I gave you as sort of templates. You should be able to make your problem fit right on top of it. And if anything is out of place, you need to do your algebra to take that away, if at all possible. Okay, so this was actually a half. Okay. So that took a lot longer than I expected, but I'm glad that happened. Because we had a lot of important lessons there. You have no idea how much what I just said is important. You really need to take that to heart. So whenever I give you the rules, it's important that you memorize them. You memorize them very specifically, very exactly. Okay. There was a comment made in the last class that I would bring up again, and it was also a violation of that principle, as you will. Right, so it was when I was asking you guys, I wrote down the difference quotient on the board and asked you guys, what is that? And I think someone said the derivative. Okay, so that wasn't exactly correct, because you're missing a very important piece, right? The limit thing in front of it, for those of you taking calculus before. So I won't get into it now, but when we do learn that, I'm gonna mention it again, and I'm like, you see, it was important to do. Okay. All right, now with that said, what about B? Yeah?
1?
1
for this? Okay, tell me how.
e to the ln cancels, you're left with ln of e.
Oh, so these guys cancel.
Mhm.
Okay, so let's rewrite that. E to the ln. So what I do is here's the base, the log is right beside it in the power, so those can cancel. That's correct. Now what?
ln e is equal to 1, 1 cubed is 1.
Ah, but that's not, this is that.
Ah, okay.
It's kind of customary when you have a notation like log, if you want the power on the whole thing, you might type it in front. So it would look like that.
Okay, so
Or it would look like this if you want to cube the whole thing. But if you just have ln of something this, you would assume that the power applies direct to the thing directly to the left, unless parentheses tell you otherwise.
okay.
So now that you know it's that, what do you say?
3?
It's 3, because now the other rule applies, where we have a log, and those will cancel and give you x. So here, ln of the he will cancel, gives you 3 as the answer. That's just a very fancy way of writing it. Yes.
That rule only applies when the log and the base and the constant are the same?
Yes, has to be exactly the same. Which means I could not do this if I had, for example, log to the base 5 of e cubed. That doesn't work anymore.
Okay.
I can't cancel those, because the base here is 5 and the base here is e. So again, the rules are very specific. Right? If it was possible for this and this to be different, we would have used different symbols. The fact that we use the same symbol is not by accident. Everything in mathematics is very pedantic, very detailed. Right? So if they use the same symbol, it means they have to be the same value. It's very important that you're very specific when you're applying something. Yes, and if you see that, that's pretty much as simple as you can get without a calculator. Because 5 and e don't play well together. Okay. Problem 2. How do you expand that? Ideas? When I say expand, I mean write as a sum of logs. In as simple a form as you can. What do you think? Yeah?
The square root is the same thing as the 1/2 power, so you can,
Yeah, sure.
and then you could go like 1/2 to the front.
So now it's log of something to a power. We're allowed to take the power, bring down to the front.
And then division is the same as subtraction, so you.
Right, log of something divided by something. So that's just log of the thing on top minus log of the thing on the bottom. Right? Another rule. Is that right? It's not right. Yes?
Well, you have to put like parentheses.
Parentheses.
Yeah.
Remember that that's in the syllabus. Very important. As written, it's not correct. That half would have to distribute to each of the things that you're breaking down. So you have to either write half twice, you need parentheses here. Okay. Is that as simple as you can get it? Yeah.
Bring the power of 3.
Right, this 3 now can come down. So ultimately, we can have 1/2 ln of x minus 1 minus 1, well, 3/2 ln of x plus 1. Right. Oh, but this is ln of a subtraction, right? So we can also distribute the ln. Right? No. You cannot do that. What I just did was illegal. Why was that illegal? Yeah?
You can only separate when they're being divided.
You can only separate when being divided. You should remember the rule. It says when you have a division, that splits up into a subtraction. Right? Subtraction doesn't split up. Logs actually can't really do anything with sums or with sums. We don't have a rule, as you might have noticed if you look back at what we did last class. There's no rule to distribute a log across a sum. That can't be done. You can split up a log if there's a division or a multiplication. Okay? So, again, the rules are going to guide you. They're going to tell you what you can do, what you can't do, and what form you need to have something in order to apply it. It's very important that they're your guides. That's how you want to think of them. These rules are your templates. You don't make a move until you can fit something, your problem, right on top of it. Okay? Very important idea to get. In fact, when it comes down to the mechanics of calculus, it's a lot of like that plug and play kind of thing. You know, with those little toys that you have babies, where there's a box and it has all these shaped cutouts, and they're the objects that you have to fit into the right cutout, or it wouldn't go in the box. And, you know, you kind of have to teach them this form recognition kind of thing. Yeah, calculus is a lot like that. Most of it is just like you have a bunch of cutout templates in your head, and you just try to fit a problem on top of the right template. When it comes down to the mechanics of it, that's kind of what it is. The theory behind it is important, but when it comes down to actually you learning to compute stuff, that's kind of what you're always doing. And that's what algebra skills are. Let's solve some equations. I really wanted to do these first, but I forgot to write them down. Maybe I'll just start with them first, because they're the easier ones, I think. How do you solve for x?
E to the 12 equals x.
How?
Because the base is e.
Right, because there's a base e
Yeah.
here. So why can you say that? What were you thinking?
The rule of how you can convert
Which
the
rule?
two.
Which rule?
That, like log of a, b to the b equals c, and then a to the c equals b.
Right, so that was rule 1. Exactly. So here, in this case, the e is your a, the x is the b, the 12 is the c, so you pretty much put this thing in that position, because it's over here, put this thing in that position, and then put this thing in that position. This is the location of all the things, fits nice to the form, put this over here, put this over there, put it. That's all it is, plug and play, templates. E to the x is 12. E to the 12 is x. There's also another way you can do this by taking advantage of the fact. Right? So So there's more than one way to skin a cat, but there are only so many valid ways to skin the cat. So whatever you're doing has to follow some rule. Another rule you could apply here is this rule. In particular, the left side. So because this is an equation, remember we're allowed to do valid mathematical operations on both sides at the same time. So if I'm given, ln of x equals 12, what I can say is, I can actually plug these both into the power of an exponential. And why would I want to do that? Because I want to take advantage of this rule on the left side. Right? I can do that to both sides. If both sides are equal, I can plug them both into an exponential and they should still be equal. And so that would cancel. And so I'd have x, and right away you get 8 to the 12 again. Questions on that? Steve. What is that? Yeah?
I got ln5.
How?
I did the method where you plug in ln on both sides and it cancels.
Okay, so you did something similar to this, where you're like, okay, if these are the same, I can plug them both into an ln, and it should still give me the same answer. You can do this, by the way, because the log and the exponential are one-to-one functions. I don't know if you remember what that is. But, these are functions such that if the outputs are the same, the inputs have to be the same. Okay, so now you do that, and you realize you can take advantage of another rule, the one that says that applying this rule to the left side, ln and e cancel, and you're just left with x. So x equals ln5. You could also, by the way, directly apply this rule. The double arrow means you can go from one side to the other. So notice that you have this side here. You can just jump back to that side at will, right? So this is like the A, that's like the C, that's like the B. So you have this kind of expression, you can jump back to that expression. They're always going to be the same. As long as you know the domain is worked out. So here x is 5. Okay, let's go something a little bit more complicated. Okay, now what? Yeah,
Take the natural log of both sides.
take natural log of both sides. So what does this side become?
5 minus 3x.
Right, so let's cancel you at 5 minus 3x.
And like bring the 5 to the other side.
Okay,
And
hopefully you don't get confused. The 4 is in the ln, not 5. Yeah.
And then multiply the 3 out to, like, yeah. Divide the other side of the
Right, so this is ln of 4 minus 5 over minus 3, or you can flip the top. 5 minus ln of 4 over positive 3. Questions on that? Solve for x. Okay, what would you get?
Well, 2x plus 1. And e to the 2 minus x. No. Minus x.
In the top,
No. Wait,
like here?
that'd be wrong, right?
That would be wrong, you're kind of seeing it?
Yeah.
Yeah. That method is kind of sketchy. You can make it work, but you're not thinking about it correctly. You actually need a law of exponents to make that work out right. You have a sum in the power. What does that mean? You actually, technically on the right side, you have some that looks like this. I mean, like that, or whatever. But the idea still holds, right? That's just another way of multiplying. So it wouldn't be a subtraction, it would be a multiplication. So, again, another common mistake here. Notice that when you plug in both sides in the power of e, it's an entire sum in the power of e. A lot of times students just take these one at a time, you have to be very careful. This you have to realize by the laws of exponents is actually that. I'll do a different way to do this problem, but if you want to go down this road, that's how you would do it. So that's just e squared, and what's this guy?
Negative, no.
1 over
1 over x.
1 over x. It's like it's like that guy. Okay, so that's 2x plus 1 equals that. Okay, algebra, how do we get that x? How do we isolate the x here?
We'll just multiply the x to the other side first.
Now what?
Take the ln of both sides, or just the ln of e?
But why? Why would you do that? Remember the goal is to solve for x, right? So if I take the ln of this thing, how does that help me to get to the x, right? I'm actually putting the x in more trouble, right? Now I'm putting an ln that I'm gonna have to get rid of afterwards. So the e squared is not the problem, right? I know that's what you don't like. You want to, that either is kind of weird. I should ln something. No, focus. We're after that guy. He's not a problem. It might look ugly, but it doesn't matter. Because what's e squared? What kind of thing is it? Yeah?
It's a number.
It's a number. It's just a constant. It's like it was a 2 or a 3 or a 7. You treat it with the same level of respect, right? If there was a 2 there, you wouldn't like, oh my god, I need to deal with that 2. You wouldn't think that, right? E squared is just a number. You're still focused on this x. How do you solve that? I have an x squared, I have an x.
Factor of the x.
No. Let me ask you a different kind of question. What if I asked you, how would you have solved that?
You add the 1 to the other side.
You would add the 1 to the other
So
side.
you add the e to the other side, and then subtract the e.
And what would you have done now?
Factor, or...
Okay, does that factor?
I mean, no, not factor, just solve for
x?
Yeah, how would you solve for x? How would you continue? Quadratic formula. This one actually factors. So I wouldn't use a quadratic formula, but that's not wrong, but it's kind of overkill. That does factor. Okay, that's what we would have done. Okay, but let's make it a little bit more challenging. Let's say we had this, and I don't know, 7 here. What would you have done then? Start out the same way, right? Move the 7 to the other side. Does that factor? Right, you have to think of two numbers that multiply to give you 7, they add to give you 2. No, right? So what would you do then? Now I'd use the quadratic formula. So it's minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, right? So we know how to do that. What do we do here? Same thing. It's just a number. The fact that it looks scary should not bother you. It's just a number like any other number. It could be in this 7, it could be a 1, it does not matter. It's a constant. Treat it like you would any other constant. It's a template. Right? There's an x squared, there's an x, there's some that doesn't have an x, that's a quadratic. That's what a quadratic is. You have a variable squared, the variable, and something without the variable. And there might be coefficients, it does not matter how ugly they look, it's a quadratic. I deal with such an expression as I would deal with any other quadratic. So what I would do here, I would subtract the e squared. Clearly that's not going to factor two numbers that multiply in, right? So I would jump right into the quadratic formula. So minus b plus or minus the square root of b squared minus 4a. Here the c is negative b squared over 2. It's important that you don't freak out. I can't tell you how many mistakes students make because something looks scary and they feel like they have to do something to not make it look scary, and they just do random things that they shouldn't be doing that are illegal because they're like, oh my god, there's a radical, I should square stuff. And it's not always the situation where you can square stuff, you know? So you need to understand what certain objects are, and it doesn't matter how they look. You can even, in your mind, just imagine it looks nicer, but just say, it's a constant, I can deal with it just like any other quadratic. So that would be the answer. I mean, you can make that a little bit nicer, but not much. So we can stop there. There's another way we could have done this. It's not going to end up much prettier, but I think it could make this step a little nicer, because I feel like a lot of students would actually make an algebra mistake at this step. So another way you could have done this is alternative method. If I do alternative methods to a problem, just pick the one you like and ignore the other one. Okay, don't become confused by it. I see that happen from time to time. Students will be like, well, I knew how to do it this way, but then I learned this method and now I'm confused, I can't do it. No, just forget the way that confused you. Learn it that way, always do it that way. Okay. So one thing you could have done is brought the ln to the other side. Because of one of our algebra principles to say if you want to solve for a variable, you kind of isolate the variable, you know, so you kind of want to get everyone with the x on one side. That would probably be a nice thing to do. This, you now know, is there's a rule that allows us to combine logs. So now we get that 2x squared plus x. And at this point, e both sides. I don't have to worry about a sum in the power and the algebra that would go along with that, so this would cancel. back to here. This one took a little more steps, but I kind of feel like this would be easier in the sense that it's much easier to not make an algebra mistake. If your algebra skills aren't the best, but you should all be working on making your algebra skills the best. And that's kind of how this one would have gone. Let's just do that because I think we're almost out of time. Log x plus log x minus 3 equals 1. How do you solve that? Combine these maybe. Now what? Yeah?
You can distribute the x in if you want to simplify that, but I also just made it like 10 equals x times x
Right.
minus 3.
So remember when it's not written, our notation is you should imagine that there's a 10 here. So we can use that rule where this is x times x minus 3 equals 10 to the 1. And expand that. Does that factor? That should be a square. What are the factors? Minus 5 and positive 2, right? And so x can be 5 or x can be minus 2. Now, is that the answer? Huh?
Oh, yeah.
No, there's a problem.
No, you can have the negative 2.
The negative 2 is a problem, right? Notice in our original, we had log of x minus 3. If I plug in a minus 2 here, that's log of minus 5. We can't have logs of negatives. So this you would reject. You can't have the negative in the log. No negative in the log. If x is 5, 5 here is okay. 5 here is also okay. So the answer is just x equals 5. I had a completely different lesson planned for today, but I'm actually kind of happy that that happened. So I think a lot of misconceptions, at least, were noted, and they're really big ones. Like if you get those under control, like if you ignore the blasphemies and get what I said today, and like really get that, like you're at a B plus A minus minimum with just those two skills automatically. Like those cause so much trouble. You need to get it through your head that the rules are your templates, you need to memorize them exactly. Do not make a move unless you can justify it with a rule. Freaking out is your enemy, right? Something looks crazy and you start doing, oh, let me just cancel it. No. All the rules always stay grounded. And think of things as manipulations and objects that you can move around. If you really understand those, and the fact that things looking crazy shouldn't scare you. Like the guy we had up here, he was a quadratic, just like any other quadratic. Don't let the fact that there's an e squared there like make you forget about quadratics. So we'll stop there. I'll give you guys back your quiz on Tuesday. The first quiz was a diagnostic, by the way, so technically it wasn't. So we're really gonna drop 3 quizzes. I just wanted to see where your algebra skills were. So yeah, I'll give you that back on Tuesday. I think the timeline this semester, because I'm teaching this class so often, I'll normally give you quizzes on Tuesday, and I'll probably post the solutions Friday night, Saturday. And hand back the quizzes the following Tuesday, something like that should be a rough timetable. By the way, web work is up, I think. Did you guys try logging in? So you log it, there's already a homework assignment up. So log in using the instructions on your syllabus. What else is there? Yeah, also check out the video, see if the view is okay, or if you want me to change it or something. Yeah, I think that's it. Next time we'll do what I actually plan to do. We're gonna start limits.
When does the homework due exactly? The homework, when is it due?
It's in web work. I think
Okay.
it's Tuesday at midnight, I think. It's a review of functions, so it's on
Okay.
function stuff.